Good morning, everybody. We are looking at today at 5D, which is implied domains and one-to-one functions. So, a function is considered one-to-one if every value of x is only connected to one value of y. So, as an example, if I just simply draw the graph of y equals x, every value of x only connects to one value of y. There is no overlap, there is no sharing. An example of sharing might be y equals x squared, where multiple values of x can actually be connected to the same value of y. So if I look here at y equals 4, there are two possible answers to that. All right, and then as I keep going up and up and up, that cubic, for example, is not one-to-one. Sorry, it is one-to-one because if you draw a horizontal line across it, it only crosses the graph once. However, if I start doing graphs like this, where I'm playing with the polynomial structure, then that creates a situation where the graph is now no longer one-to-one, because as if I draw a line across it, it cuts 1, 2, 3 times. All right, so a horizontal line test is how we decide if something is one-to-one or not. All right. So the tricky thing is deciding when to apply it and when to not. So for example, if we start looking at our good friend with the anything with an asymptote, and I draw a line across it, is it a one-to-one function? If I draw a line across it, what happens? How many times does it cross? Well, that's the question. Is it a one-to-one? Because if you draw a horizontal line across it, what happens? Yeah, it crosses once. All right, but what if I were to change the graph to a truncus? Is that a one-to-one? No, it crosses twice. What about if I do a what if I do this graph? If I draw a horizontal line across it down here, it doesn't cross at all because it doesn't exist. If I cut it here, it cuts twice. But if I draw the line at exactly the right place, it touches it just once. So what does that mean for the fact, is it a one-to-one function or not? Because if I cut it here, it only touches once. What do you think that means? Down here it cuts never. Over here it cuts twice. But along the top there, at y equals 3, it only touches once. Is it a one-to-one function or not? Because it crosses twice at some point, the entire thing is not one-to-one. It is one-to-many or one-to-two. All right? Now, that horizontal line test is just something that you guys are just going to have to remember and recognize. All right? Now, the practical component for today is the existence of implied domains. I don't need to tell you what the domain is for this graph. It is implied because the graph can't exist outside of it due to the nature of the equation. All right, because we are doing a square root equation, we can't have the square root of a negative number. Therefore, whatever x is, it cannot be more than 3 or less than minus 3. Because the moment it does become more than 3 or less than minus 3, the graph stops existing. All right, so if this graph has an implied domain of minus 3 to 3, what is the implied range for that graph? I asked you guys a question. Thank you, Bowl. Glad to see you're paying attention. All right. Graphs with properties of places that don't exist, or there are no restrictions given, have implied domains. All right, and your job is to recognize where those implied domains start and finish, and then what the associated range is to go with them. All right, so exercise 5D has questions regarding what we've talked about today.